All right, welcome back from your break. This is Dr. Matthew J. Traum. This is the second video in the second lecture of the engineering design course. This is the slide that we stopped on last time, so this is where we'll pick it up moving forward through this session. This slide talks about the abilities associated with design problem solving versus scientific problem solving. And the reason this is important is because up until now in your undergraduate engineering careers, you've essentially been taught to solve problems like scientists solve problems using a systematic and analytical process. There is an alternative, which is the way that designers solve problems, and what most undergraduate engineering students find difficult about design courses is that they do require this different sort of design-focused and synthesis-focused mindset, and shifting to that mindset is often quite difficult. So here are scientific versus design problem-solving abilities. So scientists, when they solve problems by analysis, they're typically searching for underlying rules or equations. Now think about this. As engineering students, when you are faced with a homework problem or an exam problem, what's the first thing you do? You go to your textbook or you go to your notes and you look for the equation or set of equations that describes the underlying rules to help you solve the problem. So you're actually looking for the fundamental equations that govern the system that you're trying to study. And scientists do the same thing. This approach that scientists use is also very systematic in that you start with a problem and you're looking for a single solution. And so what you'll do is you typically know the direction that you want to go, and so you'll proceed in that direction towards a solution as long as you possibly can until you hit some insurmountable roadblock, maybe some piece of information that isn't given that you just can't possibly measure. And when you get to that roadblock, then you backtrack to the place where you did have the required information to proceed, and you proceed down the second best possible route trying to find the solution. So it's a very systematic and linear process. And this is called problem-focused, a problem-focused strategy to achieve a single solution. Now once you've achieved that single solution to your problem, you're done. The problem is solved and you can move on to the next. Now, from the perspective of a designer, designers, by contrast, use synthesis to solve problems. So they're not necessarily looking for a single path to a single solution. They evaluate multiple solutions simultaneously. So they're going to look at multiple solutions, and they're going to take a more conjecture-based approach. And this is a bit chaotic because you do have to look at various possibilities, various competing possibilities simultaneously, and sort of take the approach of, well, what would happen if I tried this? What would happen if I did this? That's a conjecture-based approach. And this leads to the deployment of a so-called solution-focused strategy, where instead of looking for a single solution, you look for multiple possible solutions and sort of try them on for size and see how well they fit to the problem that you are struggling with. So from this, we conclude that design as a process is not strictly hierarchical. To give you a sense of what this means graphically, I've got this image here on the left, which is a hierarchy that goes from the top large node down a chain to smaller nodes. And this is the problem-solving process that scientists use that undergraduate engineering students are typically most familiar with. Here on the right-hand side is a non-hierarchical web where you can see a bunch of nodes distributed essentially random through the space. Some are close together, some are far apart, some are connected, some are not, and that's representative of a non-hierarchical solution space and associated design process. So given that we are, as engineering designers, living now in this world of a non-hierarchical process, how do we navigate that in a way that leads us to a viable solution? So the first tip is to identify critical details early on. And those critical details are typically identified in the customer needs statement as the engineering designer is working with the customer. Second, what the designer needs to know about the problem usually only becomes apparent as he or she tries to solve it. So you don't actually have all the information you need typically at the beginning of the process, and what's important and what's not becomes apparent as you move through the design process from the customer needs to the final communication of what needs to be built to solve the problem. So in that vein, the designer needs to synthesize a lot of information. So you have a lot of information coming at you when you do engineering design, and some of it is relevant, and unfortunately some of it is not relevant. And so you do need to develop a skill of determining how important a particular piece of information is and putting it into your thought process at the relevant level of significance, depending on whether it's important or not. However, as you move through the design process, information does need to be considered as it becomes relevant to a developing solution. So early on in the process, you might have discovered a piece of information that you thought was not relevant. You filed it away somewhere and essentially forgot about it. And then as you move through the design process, you may discover that that piece of information really is quite important, maybe even central to the solution as it's emerging from your process. And so you do have to have this kind of archive of knowledge and be able to pull from it as needed as the possible solution sets change with respect to your thinking about how to solve the problem. And then this last bullet point is the one that I like the most, in that a solution might actually require a problem redefinition or a solution outside the assumed solution space. So what this essentially means is, unlike a scientific process where the problem is fixed and you're looking for a solution, in engineering design, both the problem and the solution are fluid. And so as you move through the process, you might discover that you need to redefine the problem to make the solution that you've come up with viable. And provided that the customer is okay with you doing that, you can redefine the problem as you need to make your solutions fit. The other thing is sort of like thinking outside the box. There's a lot of assumptions about what can be done and what cannot be done, and that is the assumed solution space. And what you might discover is that you need to come up with a solution and function outside of the so-called box, the solution space. So those are important tips for how to deal with a non-hierarchical process. All right, I'm pushing over 7 minutes here, so I'm going to take another break, and then we will talk to this slide in the next session. So take a break and come back in a little bit, and we'll do this last slide.